Hello. Welcome. Today we will talk about how to get forecasts using Excel. To do this, I will be sharing with you the information that appears in my computer screen. Let us begin. I hope the screen size is big enough for you to observe the names on the columns and rows. We will begin with the simple moving averages method. Even though the formula seems complicated, this is the simplest method. To obtain a forecast, you only need to compute the average of the last 10 data values. For instance, suppose we need to get the forecast for period 21. To do this, we will use the last 5 data values. This means that in our formula to get the forecast, n is equal to 5. And therefore, in cell D23 we must enter the following formula. The result of the forecast is 301.6. As you can see, we have obtained the forecast of period 21. However, something that is important to compare forecasting methods is the analysis of the errors. Obtaining the errors is a fundamental step when we want to compare two or more forecasting methods. But besides, it is indispensable if we want to generate confidence intervals for the forecast we are obtaining, or to know its utility percentage. To obtain the errors, we compute the forecasts for the past data, which is equivalent to know what would have happened if the forecasting method had been applied since the previous periods. In this case, we need 5 data values to predict the next. So that the first value we could have forecasted must be in the 6th period. The forecast for the 6th period should have been the average of the first 5 periods. The formula to enter in that cell is: applying the formula, we obtain the value of the forecast as 289.2. Once we obtain this value, we only need to copy down the formula. And by doing this, we obtain these values. Now we are going to get the errors. To do this, we have inserted the next column. The forecast error is defined as the difference between the actual value minus the forecasted value. To be able to compute the error in a period, it is necessary that both the actual value and the forecast exist for that period. If one of these elements does not exist, it is not possible to compute the error. For instance, in the first 5 periods, the forecast does not exist, and in period 21, the actual value does not exist. Therefore, it is only possible to compute the errors for the periods between period 6 and period 20. The error in period 6 can be computed with the following formula. And once we obtain the answer, we copy the formula down until period 20. Now, I invite you to obtain the errors using this method but with n equal to 4. That is to say, to obtain a forecast you must consider 4 data values. I suggest you pause the video to perform the calculations. In first place, given that we only need 4 data values to predict the next, we can start computing our forecasts in period 5. The formula we must enter in that cell is the following. Once we obtain this value, we copy the formula down. Now, the errors can only be obtained from period 5 to period 20. The formula in cell E7 is the following. And again we copy the formula down until period 20. I hope you found these results. The next method we will see is weighted moving averages. In this method we can assume that the forecast depends on the n previous data values, but the weights these data values have in the forecast could be different. A fundamental necessary condition is that the sum of the weights must be 100%. Suppose the forecast depends on the previous 3 data values. And we will assign a weight of 50% to the most recent observed value, a weight of 40% to the value that occurred 2 periods before, and a weight of 10% to the value that occurred 3 periods ago. I will place these values in cells G3, G4, and G5. Now, given that we only need 3 data values to get a forecast, we can obtain forecasts starting in period 4. The formula we must enter in that cell must be the multiplication of 0.5 times 324 plus 0.4 times 295 plus 0.1 times 297. Referring the computations to the cells, we get the following expression. Now, my advice is that you fix the cells where the different values of alpha are shown, so that we can copy the formula down. And then we obtain the errors. I ask you to compute, as an end exercise, the forecasts and the errors considering 4 values of I hope you obtain these results. The last method we will see in this section is simple exponential smoothing. In this method, the forecast for the second period will always be the first data value. After this period, we use the formula shown in the second expression. For instance, for this data the forecast for the second period is 297. Notice that the cell reflecting this value is linked to the first data value, so that if the data value changes, the cell will be updated. Now, I will place the alpha value in cell G3. For the moment, the alpha value will be 0.1. Now, to get the second forecast we must apply the second formula, which consists in multiplying alpha times the previous observed value, plus 1 minus alpha times the previous forecast. With reference to the cells, the formula is as follows. To be able to copy down the formula, it is convenient to fix the alpha value. We will place this formula in cell D5 and copy down the formula and obtain the errors afterwards. Before ending this section, allow me to mention 2 things about this method. The term exponential is because of the following reason. As you can see in this system of equations, in this method all the data has a weight on the forecast. The most recent period has an alpha weight, and the weights for the other periods decrease in magnitude. The farther away a period is from the current time, the smaller the weight. Besides, the weight does not decrease linearly but exponentially. This is the reason of the name of this method. Moreover, as I mentioned a moment ago, alpha is the weight assigned to the last observed value. The bigger the value of alpha, the bigger its influence on the forecast. And it could affect the forecast significantly. If the value of alpha is small, then the changes in the forecast will not be too drastic and the curve will be smoother. Changing the value of alpha for this set of data, I have drawn 3 plots, so that you can compare the behavior of the forecast. In the 3 plots the data set is exactly the same we have worked in this example. The observed data is blue colored, and the forecasts are in red. As you can see, as alpha gets bigger, the observed smoothing effect on the forecast is smaller. I hope this session has been useful. I will see you soon.